In the spring of 1816, North America and Europe were finally recovering from years of draining transatlantic warfare. The foundation of this economic and social recovery was agriculture. The survival of millions depended entirely on the reliable, predictable arrival of the agrarian seasons. To track this rhythm, society relied on printed records like these antique farmers' almanacs. They acted as the undisputed guide for when to plant and harvest. But in 1816, those predictions failed completely. By June, heavy snowstorms suddenly blanketed New England, destroying crops without explanation. The anomaly quickly proved to be global. In Geneva, Switzerland, the sky grew so dark that fowls went to roost at noon, and candles had to be lit during the day. In southern China, rice paddies froze solid with summer ice. Pre-scientific societies grasped for answers.
Public theories ranged from the wrath of God to the unintended consequences of Benjamin Franklin's recent experiments with lightning rods. This diagram illustrates Alexander Wilson's hypothesis of sunspots pointing toward Earth, representing the most advanced scientific theory of the time. Scientists hypothesized that unusually large dark spots on the sun were physically blocking solar heat and causing the Earth to cool. Without the tools of modern climatology, society faced an invisible, poorly understood force. The agrarian baseline that sustained human life was breaking down, and no one knew why or if the seasons would ever return to normal. The true epicenter of the disaster was located in the Dutch East Indies. In April 1815, Mount Tambora detonated in the largest volcanic eruption in recorded history, propelling millions of tons of material upward into the sky. The eruption injected a massive volume of sulfur dioxide aerosol into the stratosphere. These microscopic particles formed a thick, reflective veil that enveloped the globe, physically bouncing incoming solar radiation back into space. The global atmosphere was already severely stressed. Ice core data reveals that an unidentified volcano, known today only as Mountain X, had erupted in 1809, nudging the Earth's climate toward a colder average. This bar chart compares the moisture and temperature impact of the 1815 Tambora eruption, shown in red, against the baseline of other tropical eruptions, shown in blue. The negative spikes demonstrate an extreme, sustained cooling and drying effect far beyond the norm. The compounding effects of Mountain X and Tambora created a massive deficit in solar energy. A localized geological event had triggered a relentless, multi-year global climate forcing mechanism. On the ground in North America, this climate forcing translated into a broken agricultural cycle. Successive hard frosts struck in June, July, and August, killing the buds on fruit trees and freezing entire fields of corn into rot. The cold was lethal. In Vermont, farmers desperately tried to tie shorn fleeces back onto their sheep to keep them alive. As their domestic livestock froze, humans turned to the forests, foraging for wild turnips, nettles, and hedgehogs to stave off starvation. With standard crops wiped out, a desperate barter economy emerged. The cold had been favorable only for producing maple syrup. Vermonters traded their excess syrup for fish, leading many locals to refer to 1816 simply as the mackerel year. In Asia, the lower temperatures suppressed surface evaporation. This reduced the land-sea thermal contrast, which completely disrupted the monsoonal circulation that millions relied on for fresh water. This heat map shows spatial precipitation variations in China during the crisis. The large, dark orange and red areas expanding across the map from 1815 to 1817 illustrate the severe, widespread drought conditions brought on by the disrupted monsoons. In Europe, endless rainstorms flooded the continent and ruined the grain harvests. The resulting famine pushed massive crowds of beggars onto the roads. Damp conditions, combined with starving, weakened immune systems, ignited a typhus epidemic that infected millions. The failure of the agricultural baseline left human populations completely exposed. Without calories to maintain their biological defenses, people succumbed rapidly to disease, turning a localized weather anomaly into a deadly global pandemic. As citizens starved, institutions faltered. In the United States, members of Congress appeared indifferent to the growing famine, opting instead to pass a law that doubled their own salaries. The political backlash was immediate and severe. desperate and angry constituents revolted at the ballot box, purging nearly 70% of the incumbent members of the U.S. House of Representatives. Even established political titans were not immune. Representative Daniel Webster lost his bid for re-election, becoming a high-profile casualty of this voter revolt. European political structures were forced to adapt as well. Facing massive economic pressure from the famine, fractured German states rushed to draft formal constitutions. It was a mandatory administrative step required to secure relief funds from the Congress of Vienna. The unrelenting weather left a mark on culture. Trapped indoors by constant rain near Lake Geneva, a group of bored writers challenged each other to write ghost stories. One of them, Mary Shelley, produced this text, the first edition of Frankenstein. The extreme environmental stress of 1816 ruthlessly swept away old political norms, forced governments to modernize relief efforts, and birthed entirely new cultural movements. Unable to survive another harsh season, thousands of farmers abandoned their barren land in New England. They packed their belongings and migrated west toward the Midwest, permanently rewiring the demographic layout of the United States. This 1850 U.S. Census data chart reveals a steep drop in adult literacy and labor force participation isolated to the 1817 birth cohort. Because extreme food shortages hit exactly when this generation was in utero, economists link this to prenatal malnutrition permanently stunting their health. For decades, society believed human progress had conquered the natural environment. The sudden freezing rot of the global harvest shattered that assumption entirely. We build our institutions on the assumption that the Earth's climate will remain stable and predictable. But when the mighty operations of nature break that rhythm, our vulnerability is absolute. If a localized event blocked the sun today, how long would our modern grid last through a year without a summer?